Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, dear students. Today we are going to continue talking about describing chemical reaction, chapter 8, section 1. We're going to continue what we said the last session, and in the same time I need you to recall what does it mean chemical equation. As we said the last time, it is so important to know about the chemical equation, which is the group symbols, number of the atoms, and the coefficient number, the number of moles that describe a chemical reaction. We are going to use this in describing a chemical reaction or writing or balancing a chemical equation. So today we are going to talk about describing a chemical reaction, chapter 8, section 1. And as I told you before, chemical equation definition is so important, and on page 252 you will find a table. The table talks about or contains the symbols used in a chemical equation. Actually, that table, it is so important because you are going to use that table symbols as long as you are studying chemistry. That's important to figure out the table. Well, okay, let's proceed. We're going to proceed with a sample problem on page 253. Actually, it is a good example to illustrate the balancing the chemical equation. Then later we're going to talk about the reversible reaction, and we're going to take an example about this. So on page 253, sample problem. The sample problem says, write a word and formula equations for the chemical reactions that occurs when solid sodium oxide is added to water at room temperature and forms sodium hydroxide dissolved in water. Include symbols for physical states in the formula equation. Then balance the formula equation to give balanced chemical equation. Okay, so first we having here sodium oxide react with water in producing what? In producing sodium hydroxide. We are going to change that word equation into symbol equation. We are going to use the symbol to write a balanced chemical equation. For sodium oxide, it is definitely Na2, and we know exactly what does it mean 2, why it is 2 here. We know that oxygen is divalent, definitely negative ion, and sodium is monovalent, definitely positive ion. So oxygen needs to react with 2 sodium atoms. In that case, the 2 sodium atom is going to donate 2 electrons for the oxygen to be stable. For that reason, the sodium is going to enter the reaction twice. Na2O, that is the sodium oxide, plus water, H2O, that is going to reduce sodium hydroxide, which is NaOH, and stop for a while. Is it balanced? This equation is balanced in that case? Well, definitely not. The equation is not balanced. And there is a question here why the equation is not balanced. To balance an equation, you have to make sure that the number of the atom in the resultant equal the number of the atom or the number of the molecules here in the reactant. Once you have number of molecules or moles different, or the coefficient number different from the resultant and the reactant, it means that the chemical equation or the equation is not balanced. Well, let's find out how to do this. Well, we got here in NaOH definitely 1 sodium atom, but in the reactant we got 2 sodium atoms. That's why we have to add 2 as a coefficient number above sodium hydroxide. So in that case it is 2 NaOH. Well, after adding any number before the compound or inside the compound, you have to figure out what kind of a change occurs to the compound in that case. But after adding that 2 here, it means that we have 2 sodium atom, 2 oxygen atom, and 2 hydrogen atom. Let's go to the reactant. Yes, we got 2 sodium atom, 2 hydrogen atom, and 2 oxygen atom. Well, in that case, the equation is balanced, and we can say that such kind of chemical reaction is going to be written like that. In Na2O, sodium oxide plus water is going to give you 2 NaOH, which is sodium hydroxide, and the equation in that case is balanced. Now let's take another concept which is talking about reversible reaction. What does it mean, reversible reaction, and how the resultant is going to reform the reactant once again? There's something known as reversible chemical reaction. What does it mean, reversible chemical reaction? Let's find that out. Oops, sorry for this. Well, okay, reversible chemical reaction as a definition, that the reactant is going to give you a specific product, but the product is going to reform the reactant again, giving the same type of reactant. And we can say that the definition is a reversible reaction is a chemical reaction in which the product reforms the original reactant. It gives you the reactant once again. So, as an example about something like that, 3Fe, we have 3 iron atoms reacting with 4 molecules of water. That is going to produce iron oxide Fe3O4, or iron tetroxide, plus 4 hydrogen molecules. But we can say this is a reversible reaction. Why it's a reversible reaction? We can notice that the hydrogen molecule, the 4 hydrogen molecule, is going to react again with the oxygen atoms here, producing the 4 molecules of the water and leaving exactly the iron atom alone. The 3 iron atoms will be alone. So that is an example about a reversible reaction. Why it's an example? Because the product is going to reform the original reactant once again. That's it. So we can say that the hydrogen molecule with oxygen atoms is going to give you the water molecules and leave the iron alone. Now let's go to the practice in the other page. It's on page 254. Exactly, just practice in the middle box in the page. And we got here 3 questions. The first one says, write the word and the balanced chemical equation for the following reaction. Include symbols for physical states when indicated. Letter A. Okay. For letter A, it says solid calcium. When the calcium react with sulfur, producing calcium sulfide. We just transferring the symbols for such words in the form of a chemical equation and find out it's balanced or not. Okay, so the calcium Ca positive 2, definitely it's divalent and it's a positive ion. When it reacts with the sulfur is negative 2 because it's in group 6A, so in that case it's also divalent. When calcium reacts with sulfur, in that case it's forming calcium sulfide, and the calcium sulfide with no coefficient number here, because actually the 2 electrons donated by the calcium is going to be gained by the sulfur, and that's it. So there's no coefficient number here, just when calcium reacts with 1 sulfur atom giving 1 mole of calcium sulfide.